We are going to learn about the difference between what is known as the exponential form of an equation versus what we call the logarithmic form of an equation. And we have to learn how to go back and forth from one form to another. And so I want to start with exponential form, and what I'm going to ask is for you to think about how you would fill in the power to make the equation true. So if I asked you what power of 2 would equal 8, you should have been thinking about a power of 3, since 2 times 2 times 2 is equal to 8. If I asked you what power of 3 is equal to 1, you should have been thinking about a power of 0, because bases raised to a power of 0 other than 0 itself are always equal to 1. I'm going to get a little trickier. If I asked you what power of 4 would give you 1 over 16. Remember, we talked about earlier that negative powers is what produces fractions where you have 1 over some power of a number, and in this case 4 squared would give you 16. So it is 4 to the negative 2 that would give you the answer of 1 over 16. Now, what you're actually doing when you're deciding what power of a base equals a number is you are calculating logarithms. So I could ask you the same question: what power of the base 2 equals 8? But written in logarithmic form, it would look like this. We call it the log base 2 of 8. Your answer would still be 3. It's just written in a different format. So if I wanted to know what power of the base 3 is equal to 1, then in logarithmic form, I could write it as log base 3 of 1, and you would still tell me that power is 0. Finally, if I wanted to know what power of the base 4 is equal to 1 over 16, then in logarithmic form, I could write it log base 4, 1 over 16, and you would still tell me that your answer is negative 2. So what I want you to notice is that in each case we have what's called a base. So in exponential form, your base is something that is raised to a power. When you are in log form, your base is actually the little subscript. Let me go ahead and make these match real quick with color. So your base here is being raised to a power. Your base in log form is the subscript. Okay, so notice in exponential form, your power is the exponent. And notice in log form, the power was always over here on the side that was by itself. Okay, not necessarily, doesn't always have to be on the right, it's just by itself. It's not with your log. And then finally, we have some number. And so you have a base raised to a power that's equal to some number. So in log form, that's what you're actually taking the log of, is that particular number. So you either have to recognize where each of the different pieces fit into each of the different forms, or you have to have some type of a process where you can accurately change from one form to another. So in terms of a process, if you look at the log form and you always start with your base, Notice the base is first over here. If you make a counterclockwise circle, notice how it's going to go in order. So you started with your base was first. We're going counterclockwise, so next is your power came second, and then it's equal to n. And so notice the n is over here. So you could do a counterclockwise circle as well. Okay, so let's take a look at some examples that you're going to see similar to that when you're actually doing the homework. So on this first one, now of course they ask you to evaluate it without a calculator. Obviously you're going to have a calculator when you're doing this, but they're trying to see if you understand how to change it or understand the meaning. So we'll just say that's equal to x because we're trying to evaluate it. Now anytime, sorry about that, a phone call was trying to interrupt my video. So anytime you see the word log and it's spelled L-O-G and there is not a base given, it is understood to be a base of 10. So what we're asking ourselves here is what power of 10 would give us this decimal, 0.001? And so if you think about that decimal, you have your tenths, hundredths, thousandths. So that's really the fraction 1 over 1,000. And as we talked before, when you have 1 over a power of some number, that means the power is negative, and 10 to the third is what would give us 1,000. So we would say this particular logarithm is equal to -3. On this second example, notice how they spell the word log as LN. That stands for a natural logarithm because its base appears in nature, and its base is understood to be the number e. If you've not heard of the number e before, e is an irrational number whose value is approximately 2.72. But if you look at the actual decimal, the decimal never ends or repeats. So we use a ln to represent the base of e. So again, I'm going to set this equal to x because what we're saying here is what power of e would equal this eighth root of e squared. Now, if we rewrite the eighth root of e squared in rational form instead of radical form, the power 2 becomes the top of a fraction, the root becomes the bottom, and I always think of it as a power flower, meaning that flowers grow above the ground, so in this case the power is the flower, and it's going to be above the ground, and then roots, they grow below the ground. And so the root in this case, or the roots in this case, go on the bottom of the fraction. Okay, so that's how you would rewrite it. So basically we're saying e to what power would give you e to the 2 over 8? Well, notice if the bases are the same, so are the powers. So x would equal 2 over 8, but if you reduce it, that actually becomes 1/4. Okay, so again, on this third one, just set it equal to x, and then change it into the other form. So let me show you this time just using going in the circle. So your base is a half. We're raising it to the power of x, and we're saying it's equal to 8. And so, again, we're trying to figure out what x is. So this kind of takes us back to that first section where we had exponential equations. We rewrite them with common bases. So if you think about the fraction 1/2, that's the same as 2 to the -1. It's still raised to the power of x. And if you think about the number 8, that's the same as 2 to the third. Alright, so if I go ahead and multiply on this left-hand side, I've got 2 to the negative x, and that's equal to 2 to the third. So now that my bases are the same, that means that my powers must be equal. So if negative x is equal to 3, and I divide both sides by negative 1, then that tells me my value of x in this case is a negative 3. Finally, there are going to be some questions that they give you either exponential form and they ask you to write it in log terms, or they may give you log terms and ask you to write it in exponential. So in this case, they gave me exponential. What I like to do is I like to first of all write the word log and put my equal sign. As long as you do not see an E in the particular equation, then you need to spell log, L-O-G. If you were to see an E, then you're going to spell it L-N. So in this case, my base in this particular problem is the B. So I'm going to put the B down here. Now if I think about the counterclockwise circle, the power comes next, and it goes over here, so the 4x. And then the number, the 2.2, is what is next to the logarithm. So that is how they would expect you to write it. They don't want you to simplify it or solve it. They're just asking you to put it in the other terms. Now, let's say they gave you log terms and they spelled it ln. And let's say they had the ln of 10 and it was equal to x plus 1, something like that. And they asked you to write it in exponential form. So again, you would start with your base, and if there's nothing here, but they spell it ln, that's when you know your base is E. As I go counterclockwise, the power is the term, or in this case terms, that are by themselves. They're not with the log, so x plus 1 would be the power. And then I would say equals to 10. And again, on those particular problems, you're not solving anything, you're just writing it in the other form.